Hi, my name is Jim O'Brien. This video is going to be about a project I'm working on. It's an off-grid solar panel tracker. Um, so what I'm doing is I'm building an off-grid RV, and what I wanted some portable panels so that I can take them with me, set them up, and put them wherever I need to get the most efficiency from the sun and the angle of the sun. So let me show you a little bit about the panel. Okay, this panel is a 100 watt panel. It's 48 inches long and about 20 inches across. It's set up so that I can angle it depending on the time of the year. You'd want to set more of an angle, 45-degree angle or something around there during the winter time when the sun is lower in the sky. And then in the summertime, the sun is higher in the sky, so you'd want it to be more flat, or whatever, but you'd like for it to be able to track the sun. And ideally what I want to do is set it up so that I can track the sun from 7 a.m. until about 5 p.m. I know that 7 a.m. is not really, you're not going to get much energy at that point, and from 4 to 5 you're not going to get much either. But that's in the winter time, but maybe we could get more in the summertime. I still need to do quite a bit of research to determine what it is. I've got some equipment that's going to be installed that will be able to monitor what kind of efficiency I get based on the angle, and also how well I'm tracking the sun based on the particular time of the year. A little bit about the panel. Let me zoom in a little. So it's a PVC pipe stand. So we've got some 1-inch PVC pipe for the legs here that go up to this T, to a piece of metal threaded pipe that's attached to this, what's called a saddle tee. Notice it's open on the top. It actually snaps onto the pipe itself, and it's glued on there. So the pipe in the center is stationary, and notice up here there's a clamp, and the clamp is loose so that the panel can move freely. The pipe stays stationary. And you'll see another one of those clamps right here, and there's one on the bottom. I don't have anything hooked up to it. That's why the electrical part that goes to the batteries and the controller is just sitting here right now. I'm just trying to write the software for this thing to get it done properly. But a little bit about this linear actuator. This is a 10-inch actuator. So the specs on this particular one is it's 10 inches, and it takes 25 seconds to go from all the way retracted to all the way extended. So what I did is I set this up so that I could start out at 7 a.m., which would be all the way retracted, and it would be facing the sun where the sun would be at 7 a.m. And then I divided it up by 10 so it could end up at 5 p.m. So for every hour, this thing is gonna go out 1 inch, and 1 inch is going to take 2.5 seconds. So 2.5 seconds for each hour will end up giving you 25 seconds. And so that would be, right now it's at all the way out, so the 25 seconds. That's as far as it goes. Let me zoom back in here. Okay. This is just another little close-up of the actuator itself. Okay, this is the front, or the opposite end. Right now I've got this piece in here that raises the panel up. It's about as low as I could get it because as the panel rotates, it starts getting closer to the ground. So this is about 6 inches right here, and so you can take this actual bottom part off and put one on that's longer, so that you can make it flat. So depending on the time of the year, I'm not sure if I'm going to need multiple of these things because this doesn't have any way to automatically um, um, change the angle this particular way. So I'm thinking that I'll have one that will be long enough to make the panel flat, and then this one, the 6-inch one, will have it on the angle, which I'm hoping is going to be good enough for wintertime. Okay, this is my prototype controller that I'm working on. So basically it's just, I got some relays. I've got a Raspberry Pi Zero, that's the controller, and I've got an LCD display, and then I've got a button. So the way this works is that I want it to be pretty much standalone. I don't want to be able to need any other kinds of software or interfaces or Bluetooth or any of that kind of stuff. I just want it to be kind of self-sufficient, run on its own. And so what I'll have here is that the LCD display will tell us just basic information about where the panel is and what state it's in and things like that. It'll probably have one line that says how much the battery is charged. All that kind of stuff I don't have done yet. But it's got a button here, and the button's set up so that if you, when the system is running and there's nothing really going on, it goes to sleep, so it doesn't draw any power. But if you press the button one time quick, it wakes it up, and then the LCD display starts up, and then you'll be able to see information about it. If you press the button for 5 seconds, then it'll go through and it'll rerun all the software to make sure that it's all calculated properly. It doesn't move the panel in any way. But if you take the button and you hold it for 10 seconds, then it's going to go through a calibration cycle where it actually moves the panel from all the way extracted, all the way extended, and back, and then step it to the particular hour it happens to be in. So here's the Raspberry Pi. It's attached to this this pair of relays, and the relays are set up so that you can take the black and the red wire here are the power to the motor. And so what happens is that if you want it to go up and down, you need to swap the polarity of these two wires right here. So that's the job of these relays. I think these relays are 30 volt. I'm not really sure. I think it's a 10 amp at AC, but it's absolutely fine for this. So the way it works is, okay, here's the connector on the Raspberry Pi, and here's the two relays. These are two separate relays, where the other one I had two relays on one board, but it does the same thing. So what happens here is that this is the wiring diagram so that we can create this table right here. And so the actual signals out here, this is signal A, this is signal B. So over here, when signal A and B are both 0, then the motor is essentially off. When B goes to a 1, then it switches the relay so that the 12 volts goes from the battery to the motor and goes into a reverse state. And then when A is a 1 and then B is a 0, then it goes into a forward state. And then a 1 and a 1 doesn't do anything, so it's considered off. So this is it. That's, it's real basic. It takes two GPIO pins for the controlling the A and the B. And then the relay is powered by the Raspberry here. I think in the final design I'll have them being powered by, there's going to be a DC to DC converter on here that'll be 12 volts off of this this battery that will convert it down to 5, and I'll run everything except for, well, probably including the Raspberry on the 5 volts that's generated by the DC to DC converter. Okay, so here's the unit that I'm working on now. I'm going to take what I had there before with on the red board and package it into this nice box. So I've got on the left, I've got my Raspberry Pi Zero. It's low power, it doesn't draw much current at all. So and this is the DC to DC converter. The DC to DC converter takes in 12 volts and sends out 5. And here's the twin relays. Probably in the next few days I'm going to wire this up and see how it seems to fit into this particular package fine. And this is the cover here, and here's the switch like we had on the other one, and here's the LCD display. Okay, here's the way that I'm trying to figure out exactly how this moves. You can see at 7 a.m. is where we start out, and then at 8 a.m. is the first time the actuator moves, and it goes from 7 a.m. to 8 a.m. and then keeps on going up, through until it gets to stage 10. And when it gets to 10, it then goes back to 7 and gets ready for the next day. So these are the 10. So every hour this thing moves up by 1 inch, and then by the time it goes all the way up to 10 inches, it's all the way over to 5 p.m. So this is what I'm working on. I got this diagram off the web somewhere, and I've been playing with it a little bit, and just to see if, for example, if the panel is really centered at noontime, and to see if it's facing the sun properly. And so far it looks correct, but I still got to do a little bit more testing. And plus I have to look at if the angle's correct to see if I'm actually getting enough energy to make this whole kind of project worth it. But it's just still all a project I'm trying to figure out. So that's it for slides here. The only other thing I want to show you is, let me see here. Okay, this is, I've got this set up on my tablet, and so the Raspberry has a WebSocket that's running on it, and all the information that the Raspberry is collecting using GPIO pins and whatever. Let me see if I can put this battery on. Oh, I'll keep that off for now. But anyways, I've got an A to D converter, and I'm monitoring the voltage. I've got a small battery here, but it's not hooked up right now. But anyways, it will give you the percentage of charge it's at. So right now it's at 12.9 volts, so it's pretty much fully charged, 100% anyways. The way this works is that right now it's 11:56 in the morning, so it should be sitting at zone 11 based on our chart, which is the 11th hour, and there's 4 minutes remaining, so 4 more minutes it'll end up going to 12. So that's just the basic kinds of things that are going to be displayed on the LCD display also. This is just an app that's running on my tablet. Right now it's running on the PC so I can do this video, but it runs exactly the same way in the tablet. So All you do is you configure the this to look at the whatever the IP address is for the Raspberry, and it's always running on port 5555. And then the device configuration is set up so that you can do different things. Like some configurations may not have an LCD display, and also maybe some configurations won't have the voltmeter. So if you get like a stripped down version, it's not going to have those, so you don't need to be monitoring those. The segment count for this one, because it is that 10-inch actuator, there's 10 segments that it goes through. So each one of the steps takes 2.5 seconds, so this is in milliseconds right here, and then fully extended for this particular one is 25 seconds. Step delay, what that is that when it's at one position, like for example if it's at position 8, which would be 8 a.m., as soon as it goes to 9, it'll go up by 20 goes up by 1 inch, which would take about 2.5 250 milliseconds. And then if it's stepping multiple times, for example, if you do a calibration and it happens to be at 3 o'clock, for example, it's got to go through many steps because it's going to go back to 7 a.m. and then it's going to go through the steps again, and each step will go to a specific spot and stop. And right now I've got that set up for 4 seconds. And what you can do with that is that if you're trying to determine, where the sun is at a particular time, you could change this to, say, for example, 10 seconds. So then for every single step it goes through, it'll wait 10 seconds. And you can actually look at the panel and see if it makes sense where it's supposed to be. So maybe you need to calibrate it a little bit or reposition the panel. And then there's some debug information that you can collect if you want to. Also, if you want the LCD display to be on all the time, or if you want it to go off after a certain amount of time. So that's about it. There's also a way that you can reboot the system, from this interface right here. But this is basically what I'm going to have set up so that I can use my tablet. It uses Wi-Fi, so I would just be able to set up the Raspberry on a dedicated Wi-Fi, and then set the tablet up to be on that same network. So that's about it. Thank you.